Keyframes in CSS are a magical feature. By changing the value of properties to create transformations for elements, generally known as CSS animation. If I add an animation delay property here with a duration of 2 seconds, our animation will be delayed and will start after 2 seconds. This is a very common feature that I believe many people already know. But what happens if the animation delay value is less than 0? We will go to the future. The time we move to the future will be the opposite of the time declared in animation delay. That is, we will move to 1 second later. So how does it work and when does it apply? Let's look at the following example. I will use the same example mentioned in a recent video and add a new feature in this video. If people have problems in the logic of creating that example, they can watch it, because that video will guide very carefully. In this video, I will go faster so that we can get to the main content, which is animation delay. First, I create a slider class as a frame for the slider display. Inside the slider contains UL. Inside UL will contain many ally tags. Each item will represent an item. Each item will be numbered in its own order and an image. These index values are variables used in CSS, helping us get the values in HTML and assign them to the calculations in CSS to make the problem simpler. Because each item will have a different position value, we have to declare it in each item. As for fixed values, we just need to write them in the parent class, such as animation creation time, total number of items. Then the child items in CSS can also use these variables. For the slider frame, I set the width to height 350 pixels. The UL tag will have a width equal to its parent class. And for each item, it will have a width of 250 pixels. Now, if I want all the items to be on the same row, I need to make sure the UL tag has a width large enough to contain all the items on a row, with each item having a width of 250 pixels. So our formula is the minimum width of the UL must be equal to 250 pixels multiplied by the total number of items. At this point, the items are on the same row, however. The UL tag generates a scroll bar because its width is too large. To solve this problem is very simple. Go to the parent class of the UL tag. Use overflow hidden to cut off the content outside the allowed range. Now, to create the animation effect of moving from right to left of the items, I will assign position relative to the UL tag and position absolute to the items. Then the items will easily move their position according to the size of the UL class. Because I want it to move to the left, the initial position of the items will be 100% from the left. Then each item runs an animation with the time previously declared in the HTML as 9 seconds. The purpose of this animation is to change the left position of the animation so that it moves to the left, and the new value will be minus 250 pixels. It worked, but since all the items moved at the same time, they overlapped each other. To solve this problem, let's look at the following simulation. In the allowed time, to avoid the items overlapping each other, we have to divide the time that the items start moving. For example, after item moves, it is item, then item. Thanks to changing the starting time, the items will never overlap each other. But the important thing is, within the allowed time, all the items must have started running. Do you notice anything in this picture? The time gap between the items is divided equally. That is, the time gap between each item is equal to the total time divided by the number of items. So if the first item is not delayed, the second item will be delayed by 1 second to ensure that it does not overlap the first item. The third item starts after the second item, so it will be 1 second later than the second item. And so on, the following items will have a gradually increasing delay time, based on the distance formula between each item. We will have the following formula for animation delay. The animation delay time of each item will be equal to the average time interval between items multiplied by the position of that item minus 1. For example, with the first item, calculate the delay time. Substitute the time, number of items, and the position of the item into the formula. The result will be 0 seconds. And the second item will be 1 second. Similarly with the remaining items. Now let's replace this formula into our code. The related variables have been declared in HTML, such as time variable, quantity variable, and index variable containing the position value of each item. So we just need to apply the formula in CSS. The animation delay of each item will be equal to the average time interval multiplied by the position of that item minus 1. And here is the result. In the previous video, I ended the video right here, and I got a lot of questions. How can this slider take up the entire screen as soon as you enter the page, instead of leaving too much space when you first enter the page like it does now? The reason this happens is because when you first enter the page, all the animations start running from the right side. And of course, it takes a little time until it moves to the left side of the screen. Notice that for this slider to cover the entire width of the screen, we have to wait 9 seconds. This is also the time that the animation is supposed to run once, right? So what if you don't want to wait 9 seconds, but also don't want to change how this animation works? Remember what I said at the beginning of the video? Using an animation delay less than 0 will take us to the future. And the point I want to go to is 9 seconds in the future. So in the animation delay area, you just need to subtract 9 seconds from the total time being delayed to make it negative. At this time, our slider will be moved to the future at 9 seconds later. At that time, our slider has occupied the width of the frame. And that's all I want to share with everyone in this video. Hopefully it will be useful in some special cases you encounter. If you find it interesting, don't forget to like and subscribe to the channel to continuously watch interesting videos about programming and web design. Thank you very much. See you in the next video.